For nearly a century, scientists have chased the dream of harnessing the limitless, clean power of the sun right here on Earth. And now China has just shattered records in that pursuit. Their experimental advanced superconducting Tokamak, East, aka the artificial sun, has sustained a fusion reaction for an unprecedented 1,066 seconds, nearly 18 minutes. That's more than double the previous record. This isn't just another lab experiment. This is a major leap toward unlocking fusion energy, the ultimate power source that could replace fossil fuels forever. But how did they do it? And why does it matter now more than ever? China's experimental advanced superconducting Tokamak, East, known as the artificial sun, achieved an astonishing milestone, sustaining a nuclear fusion reaction for 1,066 seconds, nearly 18 minutes. This accomplishment marks a significant breakthrough in fusion energy, more than doubling the previous record of 403 seconds. It demonstrates a massive leap in plasma confinement technology, a crucial step toward making fusion a viable energy source. To understand why this is so remarkable, let's break it down. Fusion energy works by replicating the same reactions that power the sun, fusing hydrogen atoms together under extreme heat and pressure to release enormous amounts of energy. In fusion reactors like East, scientists must heat plasma to temperatures exceeding 150 million degrees Celsius, which is hotter than the core of the sun. But heat alone isn't enough. The challenge is keeping that superheated plasma stable and contained long enough for fusion reactions to sustain themselves. That's what makes this record-breaking experiment so critical. The ability to maintain plasma stability for nearly 18 minutes is a sign that scientists are getting closer to achieving long-diminished controlled fusion, a major requirement for future fusion power plants. It proves that East's technology can handle extreme plasma conditions for an extended period, bringing the dream of continuous fusion energy one step closer to reality. This achievement isn't just about breaking a record. It's about validating advanced fusion control techniques, improving plasma confinement, and testing the new heating and magnetic field technologies necessary for the next generation of fusion reactors. With every new record, scientists refine their understanding of how to keep plasma burning efficiently and for longer periods, paving the way for commercial fusion energy in the future. The race for fusion energy isn't just about breaking records. It's a global competition to develop the first fully operational fusion power plant. The world's leading scientific institutions, from China to the United States and Europe, are all working toward the same goal: harnessing the cleanest, safest, and most abundant energy source in the universe. China's latest breakthrough with East puts it at the forefront of this fusion race. While fusion energy research has been underway for decades, only in recent years have scientists started to make real progress in sustaining plasma long enough to be useful for power generation. East's success demonstrates that China is emerging as a leader in fusion research, challenging other major projects like the International Thermonuclear Experimental Reactor in France. Unlike traditional nuclear power, which relies on fission, splitting atoms, and produces long-lived radioactive waste, fusion creates energy by merging atoms, leaving behind only helium as a byproduct. No carbon emissions, no nuclear meltdown risk, no radioactive waste disposal crisis, just pure energy extracted from elements as simple as hydrogen isotopes found in seawater. This is why the race for fusion is one of the most important scientific competitions of our time. The country that masters this technology first could revolutionize the world's energy systems, eliminating fossil fuel dependency and creating an endless supply of clean power. China's sustained progress with East contributes valuable data to international research efforts, helping to refine reactor designs and optimize plasma confinement methods worldwide. But this isn't just about competition. Fusion energy development depends on international collaboration. China is heavily involved in ITER, a $22 billion mega project designed to prove that fusion can generate more energy than it consumes. The latest East results feed directly into ITER's future experiments, providing crucial insights into how to keep fusion reactions stable over long periods. With every breakthrough, we're inching closer to a future where fusion energy could replace fossil fuels entirely. While commercial fusion power plants aren't operational yet, East's success proves that the technology is advancing faster than expected, and that fusion's potential as the energy source of the future is no longer just a theory. Despite these exciting breakthroughs, fusion power isn't ready yet, and the road to commercial fusion energy is still filled with major challenges. The biggest one, net energy gain. So far, no fusion experiment has produced more energy than it takes to sustain the reaction. While East's 1066-second record proves that long-duration plasma control is possible, the reactor still consumes more power than it generates. Scientists need to push beyond longer durations and hotter plasmas to finally achieve self-sustaining fusion reactions that produce excess energy, a breakthrough that would change everything. Another massive challenge is the materials used in fusion reactors. The walls of a fusion reactor must withstand temperatures hotter than the sun, while also surviving intense radiation and constant bombardment by fast-moving particles. Current materials degrade quickly, making long-term reactor durability a serious issue. Scientists are now exploring advanced heat-resistant materials that can withstand decades of operation without breaking down. Then there's the issue of scalability. East is an experimental reactor, meaning it wasn't designed to generate electricity for the grid. To power cities, scientists need to scale up fusion technology into commercial reactors capable of producing consistent power output at an industrial scale. China's next project, the China Fusion Engineering Test Reactor, seawater, aims to bridge this gap by focusing on continuous operation and energy output, rather than just experimental plasma stability. Despite these hurdles, there's real optimism in the fusion research community. The rapid progress in fusion duration times, plasma control, and energy efficiency shows that the dream of limitless, clean energy is no longer just science fiction. As ETH continues to push the boundaries of what's possible, the world gets closer to a future where fusion energy can power homes, industries, and entire nations, without pollution, without waste, and without limits. China's latest breakthrough with East is more than just another experiment. It's a historic leap toward the future of energy. Sustaining plasma for 1066 seconds proves that fusion reactors can operate for longer, more stable durations, bringing us closer to the day when fusion energy will power the world. There are still challenges ahead, but with each experiment, scientists gain new knowledge, new techniques, and new hope that fusion power will soon become a reality. The future of energy is clean, limitless, and fueled by the very forces that power the stars. The only question left is, how soon will we get there? This achievement not only showcases China's leadership in nuclear fusion research, but also signals a major shift in the global energy race. As countries invest billions into developing commercial fusion reactors, breakthroughs like this accelerate the timeline for practical applications. With continued advancements in superconducting magnets, plasma confinement, and energy extraction, the dream of fusion-powered cities is inching closer to reality. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries, and don't forget to leave a comment below. Also, you can visit our website, spaceinews.com. Thank you for watching, and see you next time.